All right, PoA, let's talk part three. It's like question four, but it's basically part three. It's all about proportional versus non-proportional, and having a sense of why one is the way it is. So something to kind of keep in mind is there's lots of different ways to tell, but in the end, proportional versus non-proportional talks about a directness or indirectness of your calculation. So if you really want to know the root of all proportionality, it's a very simple question. Can I simply multiply by a number and get my output, or do I have to multiply and then add or subtract to get my output? And this presents itself in a lot of nice little ways. It presents itself on the graph one way, the rule, of course, the table, and it's really all about picking out the right feature. So here's what I mean. If we look at this graph, or this table, and we evaluate the starts, we have a start at 5 versus a start at 0. When we covered this last couple of days, you guys have done a nice job with this. But because that one starts at 0 and this one starts at 5, excuse me, we know for this one there's going to be some addition. Because there's some addition, we know it's not a direct multiplier, hence this guy is not going to be proportional. Because this guy right here starts at 0, there is no addition. It's a direct multiplication problem, so it's going to be proportional. Okay? And that's really what you can explain over and to the right. Um, if we look at our kind of table, x, y, 0 to 0, there's going to be no addition, just multiplication, and therefore it's going to be proportional. And of course, the opposite is true for the non-proportional table. So the way this direct multiplication plays out on the graph is equally interesting. Here we have a start value not at the origin. Here we have one at the origin. So we can actually claim that this side is a proportional side. And this guy is a not proportional side. Okay? And again, it has to go with this like direct multiplication thing, but in the end, proportional graphs, proportional. Anyway, so the proportional graphs pass through the origin. Okay? In the same way, proportional tables will always have 0, 0. Proportional graphs will always pass through the origin, of course, this guy right here being the origin. So if we're looking at the rules, this idea of direct multiplication is probably the most clear. Here we have a plus 4, so that's going to be the not proportional. And here we have, well, we actually have like a plus 0, but the plus 0 doesn't have to be shown, so this side will be the proportional side. Okay, and we tell it directly because if there's addition, it's going to be automatically not proportional. And again, this has to do a lot with the fact that it's a direct multiplier, not a direct multiplier, than an addition problem. So here's the payoff. If we look at these two situations, what we have to ask ourselves is which one shows direct multiplication with no additional addition. And it's not really clear initially, but there is a couple ways you can tell. So if you're completely unclear, then what I would ask you to do is to make a table. So if we made this a table of pizzas and cost, 5 pizzas cost 50 bucks, 10 pizzas cost 100 bucks. Well, ask yourself what the rule is. 5 goes to 50. That implies the rule is going to be um, the process is going to be like 5 times 10. On this guy, it goes from 10 to 100, which implies the rule is going to be 10 times 10. So if we look at our rule as a whole, the cost of pizza is going to be 10 times the number of pizzas given. There's no addition there. It's a direct multiplier. That leads us to think that this guy should be proportional. Okay? If we look at the second one, we have this Leo ordering some pizzas, and we might get the joke there. But again, if you're not quite sure what's going on, I encourage you to make a table. So we have pizzas and we have cost. We have 5 pizzas cost us 45 bucks. We have 10 pizzas cost us 85 bucks. So if you're looking at the rule here, and it might be a little tough to pick out just a couple of examples, but we can find the rule to be 8 times the number of pieces ordered plus $5. Now, another way you can tell non-proportionality right away is the fact that if you look side by side, when I double the amount of pizzas, I actually double the cost at the same time. Someone said, I don't know who it was, but someone in class on Wednesday said something really, really nice, which was, well, if you double the amount of pizzas you ordered and it's proportional, it'll work to double the cost as well because there is no initial setup fee. On this side, I did double the amount of pieces ordered, but I should not double the cost because there was an initial piece there. 45 double would be 90, and that definitely implies that if I were to double the cost, I'm also going to be charged that $5 fee twice. Um, so, so in the end, the thing that I would really encourage you to think about is that proportionals, if I double the IV, I also get to double the DV. And for non-proportional relationships, if I double the IV, I do not double the DV. You can't double both. 45 double is an 85, in other words. All right, that's proportional relationships, guys. There's so much to that. Watch this video again if you need to, definitely. And I'll see you guys in the next part.